Hi, welcome to video number 3 in this series about ASTM D2887 full explanation. Before we get started, please subscribe to my channel. I really thanks for your support. Right, so in the last two videos, what I was covering was in the video number 1, I was talking about retention temperature and how to check whether it's a good retention temperature and how to build calibration table. In the second video, it was about reference gas oil, how to use how to verify that your instrument is doing well, is generating the result that you need to. And then in this video, we're gonna cover about sample analysis, right? For the sample analysis for this method is very simple. Let me show you that, right? So what you have to do is usually every day that you come in, that I would recommend you perform this one. I call it every startup. Okay, what you have to do is you want to run a one blank run. The purpose of this blank run to condition the GC. Okay, so how do you perform this blank run? Especially you don't need to. Usually, most of the customer that I've seen, they put a blank valve on the GC so that syringe will withdraw some air and inject into the GC. So that's not very perfect way. What I recommend you to do is you just when you define your Chemstation to run, right, in the sample location, you don't put anything there. You just leave a blank over there. The GC will understand, the software will understand that you want to run a blank. By that way, the software will not inject anything at all. We just start the GC straight away for you so that you don't need to inject any air, anything, because some of the air might oxidize your column. So that's not very good idea to run it that way, right? So that's the first one you want to do. The purpose of this one is you want to condition the GC. You want to get the GC used to the operating condition that you're going to run the retention temperature eventually, right? Then the next step, the next one you want to run right after this one is you want to run a retention temperature 2 times, right? Why 2 times? Because we need to verify whether we're repeatable in retention time and something like that. And then again, watch my video 1 to verify whether your retention temperature is a good one. And the ultimate purpose of running retention temperature is to build a table of boiling point and retention time, right? And then once you have happy with this one, you can run your reference gas oil. And this one, probably you want to run 2 runs as well to verify repeatability. And for reference gas oil, for this method, you can run a neat one. You don't have to prepare anything. So when you buy reference gas oil, just transfer some into the valve and run. You don't have to prepare, you don't have to dilute anything in CS2 or whatever solvent, right? So I would recommend when you first start up your day, this is what you should do, right? And eventually, if you have a sample, you can come straight away after this one, or if you have break in between, that doesn't matter, right? So for each sample, this is what I would recommend you to do. You want to have 2 different blank runs. So the first run to condition the GC, and so here's the point. If you are going to run a sample right after the first startup over here, you don't have to run this condition the GC anymore. You just need to run one blank, again the same way, put nothing into the sample location in the Chemstation software, and that way you will be able to perform the blank compensation, right? But if you are going to run the sample, like let's say a few hours after this startup, I recommend you to do one condition GC first with the blank, right? And then you want to run reference oil to verify that it's still okay, or just one run that should be good enough. And if this one's okay, you can proceed with your sample. So this is the typical sequence that I would recommend for this method. Again, for a sample or the reference oil, you can run them as neat. You don't have to dilute or prepare them in anything, right? So that's the sample analysis protocol I recommend. All right, so now let's get into Chemstation and SL, and we go through how to process data of the sample. All right, so again, before we process data for a sample, this is something that we need to prepare. We need to have something like a calibration table of your hydrocarbon numbers over here, and then you have retention time, and you have boiling point, which is from the retention time mixture that we have built, right? So you have this one over here, then you want to prepare a table, something like this. You have a total sample area on top here. Then you have this weight percent, and you know this weight percent is the same as error percent. Then we have a couple of this. We go through all of this, and or you can watch my video number 2 about reference gas oil. I have done 3 samples about this one. So in this video, I'm going to pick only one of them to demonstrate for you one more time, and then we focus more on the cut point table because we have not covered this in the reference gas oil, right? So All right, so let's get into Chemstation 2. Let me show you the two data of the sample that I have run. So these are two samples that I have run, and you can. The first thing you want to do, you want to overlay them and verify that they are repeatable in terms of their appearance. See, okay, they look pretty good. Okay, if they are good, then you just need to simply pick one of them to perform the calculation, right? All right, so let me pick this one. And then the first thing, of course, you want to do is something we call the blank compensation. Let me show you that one more time. The purpose for you to run the blank on top here is for the sample to compensate back the blank, because the sample will have a contribution from both the sample itself and the blank, right? So you want to perform that blank compensation first. You load the sample, and then you go to File, you go to Subtract Blank Run, then you select the blank run that you want to subtract from. Okay, this is the blank run. You say OK. Then you see the data over here. We say this sample minus the blank over here, right? Let me close this table. All right. So what you need to do for this one is you want to select this, go to Iteration tab over here, then select this button, then you drag everything so that you remove all the iteration from here. All right. And then what you have to do is you zoom in a little bit like this, and you want to get, you want to get the total sample area from here, right? And what I've done so far, I've used again the commercial software to generate this data for you. Then later on you can compare whatever you have from here with this data, and also the cut point will be the same thing. Okay, for this data, I start the iteration from 0.5 and stop at 20. So I'm going to do the same for this data. 0.5 to 20. Let me zoom out a little bit more. Okay, 0.5 to 20, that will be something like this. 0.5 is somewhere here. So that will be something like, you can zoom in a little bit more if you want to, but it will be something like this. Right. So once you have this error count, that will be your total error count. Right. That will be 400. Let me enter that. 400. 9413.3. 9413.3. That. So this is your total error count. So let's go through this table, and I don't know which one you want me to perform a calculation. Let me pick 70%, for example. Okay. So 70% of weight, that will be the same as 70% of error counts, right? Because as I say, this method assumes the full illusion as well as the same response factor for the entire chromogram. So that means the weight percent is exactly the same as the error percent. So for 70%, that basically means 70 times error count on top here. So that will be 2 point, let me change this one to zero number like this. And then you have, let me put like this, okay. Okay, 2.8 million error counts. So that means the remaining will be this one minus this one. Okay, you have like this. Okay. All right. So next step, we want to find out the retention time corresponding to 2.8 million error counts over here. So let's do that. Okay. And the first thing you want to do is you want to have like a sense of 70%. Where should it be? I think it should be somewhere around here. You don't want to start somewhere with too little. Here is too much, right? So you want to start, again, you hit this one to split the iteration. I want to start somewhere here, right? And that will give me 3 million something over here. And here I need 2.8 million. So that's a little bit too much. What I can do, I can remove this iteration so that I can change the position. And again, this one will not be available unless you select the signal that you want to undo, right? And when I select this one will be available, I will remove that one will go. Okay, so because just now a little bit too much, I want to go back a little bit here. That will give me 3.3 million. So that's still a little bit too much. Remove, go back somewhere here. Now I get 2.9, so getting closer. Now I need 2.8, right? But here is 2.9, so that's a little bit over. Then remove again, go back somewhere here. That is 2.7, so that's a little bit quite close to this one. All right. So what I need to do, I can zoom in a little bit more, like this. Okay, so here is giving me 2.7. So what I need to do, I can keep this one as my reference point so that I don't. I can click this one. I can select another one. Let's say somewhere here. So that will give me, now what you need to do, you need to take this error count plus this one to end up with this one, right? In order for you to compare with this number. But that will be a bit difficult for you to do like that. So that's why I recommend you to have this column total minus the error, which is the remaining. So remaining is 1.202, 1202. So that basically this is the last column over here, right? And we are getting 1203. That's very close. So we need to get this one a little bit lower, right? So that means we need to move this one a little bit to the right side, right? So right now it's here. I can zoom in a little bit more, and then I can select this one, zoom in a little bit more, 1202. So that's there, right? You get 1202 remaining. So that means from beginning until this point, that is the error count of 2,800,000, right? So, so you have this is the correct retention time that you need to take. What you have to do is zoom in over here and you take the number. So that will be 3.4894, right? 3.4894, right? So that's the retention time. For the boiling point, again, what I need to do over here, this is the x-axis, this is the y-axis. So that means the formula will be boiling point equal to slop time, retention time, plus intercept, right? All right, all right. So what you need to do is 3.48, what you need to do is to figure out which are the two hydrocarbons that we cover this 3.48, which is C8 and C9 over here in this case, right? And then for the boiling point calculation, we use this formula on top here. That will be the slope and known Y. Just now we say 3.4 or something. So that will be C8, C9. So known Y is here. And then known X are here. Time, the retention time, and then plus the intercept, known Y, then known X, right? There you go. So you get 150.1 degrees. For this commercial software, it's come up with 150.4. So that's pretty close. So I think we are good with that one, right? So that's the way how to perform the calculation for your sample. You can come up with whatever number you want from here and perform the same calculation, right? But for this video, I will focus more a little bit on the cut point again, because this one we have not covered before. All right. So for the cut point, is a little bit different. You define a range. So the range is the starting and the ending, and then from there you want to report the percent of your sample in between of those ranges, right? So the range could be a temperature, it could be a carbon number, it could say SET, which is the starting, or 0%. It could be EET, that's 100%, or it could be IBP, or it could be FBP, 99%. All right. So let me show you a couple of them over here. If I need to show a cut point from IBP to EET, so even if you don't perform a calculation, what should it be? So IBP we know is 0.5%, and EET is all the way to 100%. So that means in between we should have 99.5%, right? So here's the result. We don't need to perform any calculation. We still be able to come up with that, right? So I'm not going to perform calculation over here. Okay, but let me write in here, IBP, EET. So that will be for sure 99.5%, right? Okay, the next one is SET all the way to FBP. What should it be? So SEC we know is 0%, FBP 99%. So that's, oh, sorry, 99.5 here. That's FBP. So for sure from 0 to 99.5, in between, that's definitely is 99.5, right? Then the next thing you can do is SAT all the way to 200 degrees. So this one we have no idea, right? So how do we perform the calculation in this case? So what you need to do is SAT we know for sure is 0%. So what you need to do is we need to come up with this 200 degrees is how many percent, right? Then from there we will to tell what's the percentage from here, right? So how to convert this 200 degrees C into percentage? So that will be a little bit different from this way. So what you need to do over here is you need to have so this is the boiling point, which is the Y value from here. And what you need to do is you plug this number inside into this, and 200 degrees is somewhere between C11 and C12, right? So what you need to do, this is 200 degrees C. Let me put like this. Let me perform something like this. So this is 200 C, right? You want to convert this one back to retention time, right? Okay. So that will be, so you have boiling point there. Okay, so that will be retention time, and so that means, let me think, 200 degrees C. Let me how to put that one. So 200 degrees C is somewhere between C11 and C12. I think let me do like this for you. So you know that a boiling point over here, you want to come up with retention time, right? So that will be boiling point minus intercept divided by slot, right? So keep in mind that formula. So that will be boiling point, boiling point, which is here, minus the intercept, right? My intercept, the intercept of this, no, it's missing R over here. Okay, known Y and 200 C is between these two, so known Y is here, the known X is here. All right, so this is the intercept, and then from the whole thing divide by the slot, and you get the retention time, right? Slot over here, that will be known Y again, then you get the known X again. All right, so that will give you the retention time. That is 5.1598. So what you have to do over here is the next step. This one is retention time, right? Then what you have to do, you go back to Chemstation over here. Okay, you remove whatever manual iteration we have done before, so it will be easier. All right, so you have only total error counts from here, and the calculation gave us 5.1598. What you need to do is go over here, 5.1598. So 5.151598 is somewhere here. 1598 is somewhere here. So just zoom in until you see that 5.15 is somewhere here. 1598 is somewhere here. Okay, 159 somewhere here. So that means you just click this button and you 1598 is somewhere over here. Just click this button like this. So that's way the software will split the line right at that retention time, and you manage to get this error count from here. So that means that will be, let's copy that one over. That means 363. So that's 363 1898.8. Okay. 1898.8. So this is your area, right? Area, right? Okay, so how do we convert to percents, right? So we have the area over here, but we have the total areas on top here. So that means this one will be this one times 100 divided by this number. Then you will get, let me change this one to a normal number. You get 90.6%, right? Of area, right? Percent area, right? And you know that 90.6% area is the same as 90.6% of percent weight, right? Right? So that means, how do we report this one? SET 200 degrees C, you can replace it 200 degrees C is actually, you can put 90.6 over here, right? Oh, sorry, 90.6. Right, and we want to report from SET to 90.6, so that is SET is 0 to 90.6, so in between that definitely is 90.6%, right? And for the software, the commercial software it shows 90.33, so we are quite close, right? So that's the way how you perform the calculation. It basically is very similar to this table over here, but just instead of you starting from weight percent, you come up with the boiling point. Now you start from boiling point, you go back to the weight percent, right? So that is one. Okay, so let's try one more over here, and then we have to understand. So this one is 100 degrees C and on the way to C30, right? So that will be a little bit different over here. So the first thing is 100 degrees C. What you need to do is the same thing over here, 100 C, and you want to convert this one to retention time. And in order for you to do that, you have to figure out 100 degrees C is between C7 and C8. So that will be the same thing, equal to, see the formula on top here, retention time will be boiling point minus the intercept. Boiling point is here. Let me put down in the bracket. All right, minus the intercept. All right, so 100 degrees C starts with between these two. There you go. And then divide by the slope, node Y, then node X over here. There you go. So you get the retention time over here. That should be 2.025, right? That's the minutes over here. Then from here, what you need to do, you go back to this one. Let me remove the last iteration. Okay, remove the last iteration here. Then you want to zoom in into that's 2.025. 2.025 somewhere here. 2.025, there you go. So what you need to do is click this one, and it's right here. It's split 2.025, right? And the error count you're getting is 1428. Just mean 1428. 119.8. So this is the area. And then what you need to do, you convert this one to percents. This one times 100 divided by the total errors on top here. Then you get percents over here. Change this one to this. Okay, you're getting 35.6% error percent, right? And that's equivalent to 35.6 of weight percent, right? So you're getting 35.6 from here, right? Now let's say C30. How do you perform the C30? So C30 is basically, again, C30 is somewhere between these two, and you don't have the retention time for these two. What you need to do is, what you can do is, basically it will be the same in between these two, and typically what the software does, it will have a store value of C30, so-called boiling point, and then from that boiling point that will be come up with something like a boiling point over here, and then from there you just do the same thing. You convert to this retention time, convert to area, convert to this one, convert to this one, right? So C30, I don't know what it should be right now. I don't know what's a boiling point C30 here, so I can't perform a calculation for you to compare, but that's typically the way. So C30, again, one more time, even if it's not in your cal table over here, if you have C30, you know that the software, or even you can see in your so-called SIMDIS, they will have C30 boiling point from there. Then if you have a boiling point, you just need to convert this boiling point over here into the weight percent, and then you take the one in between that we will for you to report from 100 degrees to C30 over here. That's you get something over here, right? Okay, so I hope this is something that you enjoy so far, and this is the way that we use Excel and Chemstation to perform all this calculation. And as you see so far, the data that we generate from this Excel and Chemstation are pretty much very close to the commercial software. So we should be good to use this software, this Excel and Chemstation if you want to, but it will take a lot more time. So in my next video, which is the last one, I will be covering the same thing over here all over again, but using the commercial software, one of the commercial software that I really like a lot. So that will give you like just within a few minutes probably, you should be able to generate everything from it instead of doing one by one like this. It will be very time consuming, right? All right, so I will see you in my next video, and I hope you enjoyed this video. Thank you very much for watching, and let me know in the comment if you have any questions, and don't forget to subscribe to my channel. Thank you. Bye bye.